This module covers organic synthesis of cannabinoids. So we have learned up to this point that cannabinoids can be sourced naturally by extraction and then further processing and refinement. But we can also source cannabinoids by organic synthesis, which means we are going to take individual precursors and put them together in an organic chemistry reaction to make the final product, the cannabinoid. First, let's talk about functional groups, because the functional groups in a cannabinoid is actually what drives the organic synthesis. So in CBD, we actually have two six-membered rings. We have this six-membered ring that contains the cyclic alkene as a functional group, and then we have another ring which is the aromatic ring. We also have these side chains. These are the alkyl side chains, and actually these vary depending on what series in the cannabinoid phytotree you're in. Then we have phenolic hydroxy groups, which are alcohol groups. In CBD, we have a terminal alkene. And here, this is an important factor because this is a trans-substituted cyclohexane ring, which means the trans configuration means that this wedge points towards you, and it's out of the plane, and this dash points away from you. It's behind the plane. So that means that the hydrogens that are attached to it are also in a trans configuration. THC has some similar functional groups, but it is a tricyclic molecule. Again, such like in CBD, it has that cycloalkene ring. It also has the aromatic ring with a phenolic hydroxy group and the alkyl side chain, which is, by the way, 5 carbons. But now it also has a cyclic ether. And the configuration around the cyclohexane ring is still a trans configuration, but because of the cyclic structure here, this is more of a cage type structure where the ring is more locked. So let's talk about how CBD, instead of naturally derived and extracted, can be synthesized. You use two precursors, this monoterpenoid and olivitol. And in the presence of an acid, you can make a major product, which is the natural one. And then we also have another one, which is an isomer, also referred to as the irregular CBD. So the difference between the natural one and the irregular one is the functional groups here, the hydroxy group as well as the alkyl side chain, they're basically switched in positions. Then you also have the THC synthesis, which also starts with a monoterpenoid and olivitol, but this time we're using a strong acid, a boron fluoride etherate in the presence of magnesium sulfate, and the temperature has to be pretty cold. And that gives the natural THC, which is the major compounds, but it still requires purification by chromatography. And we covered lots of material about chromatography in Module 5, if you need to go back and review what that entails. CBN synthesis is something I wanted to go over real quick because you have an assignment on that. And it starts with delta-9 THC, or CBD, and then you can use 3 reagents that will do what we call an oxidation, and this oxidation can be achieved either by using sulfur or DDQ or chloranil. DDQ is oftentimes a little bit more powerful than chloranil, or iodine. These are the 3 synthetic routes that are currently used to convert THC CBD into CBN. And the reason why I wanted to bring this up is because I am going to talk about this term called oxidation. So here you have that cyclic alkene in THC and CBD, and when you do this reaction, you're actually making an aromatic ring, which means you're taking hydrogens away. And taking hydrogens away in organic synthesis means an oxidation, whereas the reverse is true as well. When you add hydrogens, that would be a reduction.